Alright, so now we're going to move on to the 5th page. This one has a lot of problems on it, but they're really not too long, so I might try to just put them all. Might do 20 in a different video if we are just taking a while to do it. But let's start with 16. Here we're being asked to condense each expression into a single logarithm. So here we have to remember our log rules, which said if we had log A plus log B, we can combine this by doing log of A times B. If we had subtraction, we would divide A and B. And then if we had a coefficient out in front, and I think in our book we always show that as a C. If we had a coefficient out in front, that would move in and actually become a power on what's inside of our log. So again, we can go back and forth between these two. So if we're going from the top one to the bottom one, that's called condensing. If we went from the bottom one to the top one, that would be called expanding. You do need to know both ways, but this one problem that we have is only for condensing. On Tuesday, we'll talk about expanding, if one of you guys remind me. All right. So here, first, let's always use our power rule first. All right, let's see if we can use it here. It just ends up being easier if we can use this one first. We can use it because we have that 5, so we have log x. We didn't change anything there yet. Plus, and then we're going to move that 5 as an exponent on our y. So that's using our power rule for logs. Now we have our addition, so we have to use our addition rule, which is sometimes called our multiplication rule. And we're just going to say log of x times y to the 5th. So this is condensing it. Remember, this xy to the 5th is all inside of the log. And remember, we don't see a base on the log, but that log has a base of 10. So we could always write it like this as well. If you don't see a base, that's a 10. I as well mention it here too. If you see ln, that is the same thing as saying log base e. E is that very special number that's about equal to, I should do the wavy equal sign, 2.71. All right. So these are basically all the rules about logs we need to remember. We will have one that pops up in a second. And how to convert between logs and exponential. But on Tuesday, we'll try to remember to talk about how to expand one log into many different ones. All right, so let's move on. This hot pink is a little too crazy. Let's just go back to blue. So here we want to solve this equation. We will end up using, always when we're solving equations like this, we will end up converting to the other form. Here we start with exponential. So we're going to end up converting to log so we can plug it into our calculator. So here we want to start getting our variable by itself, which our variable is all the way tucked away up here. So let's deal with this minus 2 first. So we can add 2 on both sides. So we get 11x plus 8 equals 67. So we have that, and unfortunately, the only thing we can do next would be to rearrange this and convert it into the log. So the rule we have for that is if we have y equals b to the x, we can go back and forth between our forms by saying x equals the log base b of y. So in our example here, our base is 11, our exponent x is actually x plus 8, and then our y is 67. So when we write this, we get x plus 8 equals log base 11 of 67. At this point, we can plug it right into our calculator, or we can still solve for x. That way we can just do one foul swoop in our calculator. So we can just subtract 8 on both sides, so we get x equals log base 11 of 67, and then once we find that, then we can do minus 8. This is when we had, unfortunately our calculators are different at this point. If we have a newer calculator, usually the black new ones, we can plug this right in and not have to worry about anything. If you're using one of my yellow ones, we have a little bit more work to go. So what I'm just going to do here is break down our work into the older calculators and the new calculators. So new, we can plug it right in. We have to press the math button and then go to A, which is called log base. So I'm going to try that again where I actually show you on my calculator, which is just a bit funny. Alright, so let me go to my video, my camera, sorry. Alright, so I want to go on, get out of here. Again, I'm clicking, if I have this newer calculator, I'm clicking the math button, going down to log base, clicking OK. I'm doing log base 11 of 67 and then minus 8. So when I get that, my answer is negative 6.246, blah, 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 blah. The instructions do say round to the nearest 10,000th, which means 4 decimal places. So if I look at here, my decimal place would be right after the 5, so the next number is a 0, so I don't have to change it here. So again, that would be negative 6.2465 would be my answer. So let's add that to our notes real quick before we forget. So that was x equals negative 6.2465. If we have an older calculator, we don't have that special ability, so what we have to do is use our change of base function to actually do this. So remember what we said here, to plug this in, we would need to do log of 67 divided by log of 11 and then minus 8. So let's see what that looks like on a calculator. Alright, so here we have to do just pressing the log button, right, just the one that says log, which is actually log base 10. We would do 67, what's inside the parentheses, then divided by log of 11. Alright, so here we get this, and then we minus 8 at this point, and we get the same exact answer. So it's okay to do either method, doesn't matter, we still get the same answer. We just have to show our work in a little bit different of a way. Alright, so that's number 17. 2 different ways depending on what type of calculator you have. So hopefully you remember this. For number 18 and 19, we're just using one more rule about logs, and I will end the video at this point. One more rule about logs, which says if the base of exponentials are the same, then we can just ignore the bases and set the exponents equal to each other. Or if our logs have the same base, then what's taking the logs of, we can set it equal to each other. So here we do have 2 exponents that have the same base, so we can kind of just cross out the 6's and say negative p minus 2, say negative 2p minus 2 would equal negative 3p plus 3. So at this point we just have 2 linear binomials equal to each other, so that is kind of fun to set equal to each other. To solve now, so we can plus 2p on both sides, so we get negative 2 equals negative p plus 3, and then we can minus 3 on both sides, so we get negative 5 equals negative p. So now we just have to divide by negative 1, so we get p equals 5. Alright, so that would be our answer here. Alright. The other one, though, we almost have log base 2 on all sides. Unfortunately, we don't. So we just need to combine our 2 logs together, and remember we said we have subtraction. So the way we would combine these 2 logs is end up doing division here. Alright, and then if we only have log on one side, that's when we need to convert to the other form, which here would be converting into from log into exponential. So our 2 stays the base, but then we kind of swap the other 2 pieces. So we get 2 raised to the power of the 5th equals 2x over 3. I'm just going to do 2 to the 5th real quick, which is equal to 32. 2 to the x, 2 times x divided by 3. So we can start solving for this. So we end up getting 2x equals 3 times 32, which is 96. So divide by 2. So we get x is equal to 48. So that's how we could solve it. There's tons of different ways for solving these. We could somehow try to have 5 look like log base 2, which if we did that would be log base 2 of 2 to the 5th. And we could use that to end up getting to this step anyways. So whatever you think is easiest, you could try to make them look like there's 2 logs, both of the base of 2, or just do what we did here, which is converting into exponential. So I'm going to end the video here, and then we'll pick back up at number 20 in the next video.